All right, welcome to LouTube and this lesson on factors. This is a new lesson for grade 10 math students, so usually not introduced till about grade 10. Some grade 9 students may have seen this before, and you may have heard your grade 7 or 8 or grade 9 teachers talk about factors before, but this is really the first time we're going to start using factors and using a skill called factoring. So we need to get a little more in depth than we normally do. All right, so factors are numbers that can multiply to make the number you have. I like to sort of say it in a real simple term. Factors is like making a multiplication question. That's what I like to think of it as. And the example I use here is an example for 10. Okay. 5 and 2 are factors of 10 because 5 times 2 equals 10. All right. Now we also have 10 times 1 equals 10. So 10 and 1 are also factors of 10. But essentially, if you're asked to factor 10, you could have the number 10 and just turn it into 5 times 2. And that would be an example of factoring the number 10. Now, some numbers have more factors than others. For example, the number 12. What are the factors of 12? Well, 1 times 12. Any number can be always 1 times itself. So itself and 1 are always factors, okay? So there's no number, no whole number that does not have at least that as a factor, okay? In fact, prime numbers, that's all they have. All the prime numbers have just 1 times themselves, okay? Then in this case, 2 times 6 is a factor and 3 times 4. Therefore, the factors of 12 are 1, 2, 3, 4, 6, and 12, if we're going to list them in order from smallest up to the largest. And these are all numbers that will divide evenly into 12, and we call them the factors, right? Let's move on up. Some numbers have no factors except for 1 in themselves. These are prime numbers, I already mentioned that. So 1, 2, 3, 5, 7, 11, 13, 17, and can you think of the next one? I'll leave you to come up with them. These are the prime numbers. Prime numbers are not divisible by any other number, and so you can come up with quite a few of them. The list goes on and on. There are prime numbers that move up the scale, okay? Factors of 8. Well, what we do is we say 1 times 8 and 2 times 4 are both multiplications that are factors of 8. And so therefore we have factors of 8 are 1, 2, 4, and 8 itself. Okay. Now it's interesting when we start looking at negative numbers, but essentially what happens is any number that is positive as a factor can also be negative. But the way it works is, say, for example, 1 times 8 will give me 8. How can I make it negative? One of them has to be negative. So another option, one option would be minus 1 times 8. Another option would be 1 times minus 8. And so essentially both minus 1 and minus 8 now become factors, okay? Now, theoretically, you could do the same thing with your positives because you could say minus 1 and minus 8 could be factors. So even when we're talking about positives and negatives, it really doesn't change anything. The factors are really the same. It's just knowing that one will be positive and one will be negative in order to get a negative answer. The only way we can multiply two numbers. So we could also look at it from a 2 times 4 perspective. So it could be minus 2 times 4, or it could be positive 2 times minus 4. Either way, all of these options give us negative 8. We still say the factors are 1, 2, 4, and 8. We just realize that when we're getting a negative number, one will be negative and one will be positive. And up here, we know that either both are positive or both are negative. But the factors of any number can be positive or negative, okay? So when the number is positive, the factors will both be positive or negative. When the number is negative, the factors will have one negative and one positive, and we kind of state that. But it's important to understand that concept, but it doesn't change the actual number of factors that you have, okay? So what I like to do for kids is ask them to complete a table that shows all the factors of all the numbers all the way up to 144. So I've completed the start of this here by listing the factors of all the numbers 1 through 9, and I'm leaving you room to fill in and do yours here. So for 11, since it's a prime number, it'll just be 1 times 11, and then for 12 it'll be 1 times 12, then 2 times 6, and 3 times 4. And your job is to continue this chart all the way down and complete it right to 144. Not a really difficult lesson, but it is a bit time consuming, especially if your timetables aren't that good. So if you have, you don't want to miss any. You want to try to make sure you get them all. So the best thing to do is say, for example, you're doing a number like, I don't know, 32. Take 32 and will it divide by 2? Yes, it will. Okay. So 2 times 16. Will it divide by 3? No, it doesn't divide evenly by 3, but it will divide by 4. And so you can write 4 times 8. And then you keep looking to see if there's any other numbers that it will divide by and write them all in here. And you can keep doing that all the way down for all these numbers. And it can take some time. I strongly recommend you use your calculator to double check. And then on next week, you can compare with your friends. And what I do is I allow students to use this factors list anytime they want throughout the course. It's sort of like your calculator for factoring. Instead of having to reach for your calculator or know it in your head, you can actually count on your factors list. But it must be handwritten and it must be done by you. That's just my rules. If you want to use it, you have to write it out. And once you've done that, it usually helps you remember it a little better. I don't suspect you'd remember every single factor of every number, but it will help you get through it. So that's your activity, your lesson for today. Hope you enjoy it, and we'll see you on YouTube next time.